All right, welcome to video number 2 in the line. This will be problems 2, 5, 8, 11, ... So let's get started. Number 2, the function is given by this thing. The solutions to which of the following equations between 0 and 2 pi are the solutions to this thing equals a half between 0 and 2 pi? Okay, this is a confusingly worded question. But basically it wants to know which one of these equations has the same solutions as this equation. I don't want to solve all 4 of these. I'd rather not solve one of them. Let's solve this one and then we'll see what we can do from there. So the cosine is equal to 1/2 at pi over 3 and 5 pi over 3. But that means my argument then, x plus pi over 6, needs to be pi over 3. I'm going to write it separately because I'm going to need to subtract pi over 6. That needs to be pi over 3, or the argument could be 5 pi over 3. Now, if I subtract pi over 6, pi over 3 minus pi over 6 is pi over 6. 5 pi over 3 minus pi over 6, that one's a little bit harder maybe. So that'd be, 10/6 minus 1/6 is 9/6, also known as 3 pi over 2. Okay, so these are the 2 solutions to this equation. Now I want to know which one of these has the same solutions. Well, I suppose I could try to solve these, but it would probably be easier to just check these answers into these and see which one works. And I probably want to try 3 pi over 2 because that's an easier spot to deal with. That'd be down there at -1. So let's try 3 pi over 2 and see what happens. Cosine 3 pi over 2 is 0. Sine of 3 pi over 2 is -1. 0 minus -1 is +1. So I'm thinking it's A, but I haven't checked pi over 6. Also haven't checked the other ones, so I'm not sure. Cosine 3 pi over 2 is 0. Plus sine 3 pi over 2 is -1, so that one's out. Sine of 3 pi over 2 is -1, so -√3 minus 0, that's out. Another one, -√3 plus 0, that's out. So it's pretty much got to be A. I suppose I could check pi over 6 to make sure. √3 cosine pi over 6 minus sine pi over 6. That's supposed to equal 1. Cosine pi over 6 is √3 over 2. Sine of pi over 6 is 1/2. 3/2 minus 1/2 is 1. That's true. So yeah, now I've definitely confirmed that A is the right answer. Kind of a tricky question. The first part's not too bad, but then figuring out which answer matches that is the hard part. Number 5. A function given by that thing. The solutions, this is the same kind of question. So which of these equations give me the same set of answers as this equation? So I think I'll approach it the same way. We'll solve this one, and then we'll see who matches. Well, can't solve that one yet, but I know that sine squared plus cosine squared is 1. So sine squared is 1 minus cosine squared. Okay. The ones don't go away. So I get negative cosine squared plus cosine of x plus 2 equals 0. But then I start looking at my answer choices. I'm like, wait a minute. I don't really want to solve that, but I don't think I have to solve that. Because if I change all the signs, then it becomes the same equation as B. So it's different than that last one. The last one we had to find some solutions and then match them. This one, once we made a substitution, we could see that the equations matched. Number 8. This is a real confusing way to ask this question. Right triangle, hypotenuse is 1, side length x, angle opposite is 5 pi over 12. Which of the following is the value of x? Well, this makes me think of pluses and minuses and sines and cosines. If I look at my triangle, the sine of that angle is opposite over adjacent. Opposite over hypotenuse, so x over 1. So x is equal to the sine of 5 pi over 12. And they're sort of giving me a hint here that, hey, don't forget, you could rewrite 5 over 12 as 3 over 12 and 2 over 12, which would be pi over 4 and pi over 6. And now you've got a sine sum problem, and I bet it matches one of those. Sine of the first one, cosine of the second one, plus vice versa, cosine of the first one, sine of the second one, root 2 over 2, root 3 over 2, root 2 over 2, and 1/2. So which one of those matches up to that? Well, C and D have a minus sign in there, so they're out. I think it matches to B. So a creative way to ask a problem that forces you into using the sine sum equation. Number 11. How many values? And I look at my answer choices, and I've got some odd answers in there. None, infinitely many. It doesn't restrict my interval, so I'm thinking it's either infinite or none, because it wouldn't be 1 or 2 if we're looking at the whole number line. So let's see what happens. Sine squared t minus 1 equals 0. Sine squared of t equals 1. Sine of t equals, don't forget the plus or minus 1. That happens at pi over 2 and 3 pi over 2. But be careful, that's only the 0 to 2 pi answers. If you want all the answers, well then you add 2 pi to those as often as you like. And you get infinitely many. Number 14. Okay, there's a rocking horse problem. There's the equation for the height of P. How many times will P touch the ground? So that would be where P equals 0, basically, or H equals 0. Well, a bunch, I guess, is the question between 0 and 300 seconds. Maybe a graph. Yeah, a graph would be the right way to go. Midline is 6. That's 6. Amplitude is 6. Cosine starts at a max, so it starts at a max, goes down to 0, comes back up. There's our 0. That's what we want to happen. So there's once, but that's what's the period of this thing? Period is 2 pi over b. So the period is 6. So it happens once between 0 and 6, but we're not going 0 to 6. We're going 0 to not 12, not 18. All right, dot, dot, dot. So once every 6 seconds it touches. 300 divided by 6 is 50. The graph of the sine function is in the xy plane. Which of the following is greatest? The length of the interval, go colors here, the length of the interval where f of x is less than 5. So that would be from there to there, where the graph is below 5. So that's 1, 2, 3, plus at least a half on either end, so that's about 4, maybe a little more than 4. We'll see if that's enough, accurate enough. That was this one. between 5 and 6. So f of x is between 5 and 6. Well, that's not a very wide window. That's that window and that window. So, I don't know, less than 1, whatever it is, not more than 4, for sure. Part C, I want my function to be greater than 9. That would be this distance. So what is that? 1 plus some on either end, so maybe 2, maybe a little more than 2. 2 plus, but definitely not 4. So he's out. And then the length of interval that satisfies greater than or equal to 10, yeah, that's only one spot, so the width of that interval is 0, technically. So it's A. That's the longest interval. Number 20 is with a calculator. Your test doesn't have a calculator, so you're welcome to try it. I'm trying to remember what the answer is. I know I did it. You would just graph this as y1 and graph 72 for y2. Let's see, a sine wave is going to look like that, although it's been shifted to the right 90, so there's 90. So who knows? And you want to know where it's greater than, started at 70, where it's greater than 72. So you need to figure out those 2 points. Figure out how wide that region is. There aren't any calculator questions on the test, so it's a good one to look at, but there won't be anything quite like that on the test.